So in the beginning, like we have talked about the Bohr's atomic model in my previous video. So according to that, Bohr said that this is nucleus and electron revolves around it, and electron is a particle, right? But after that, many scientists came and they proposed their theories. So there were two scientists known as de Broglie and Heisenberg. So according to them, electron is a wave. Like de Broglie proposed an equation. He proposed that a body is a dual nature. A body has a dual nature. According to him, he proposed an equation which was lambda is equal to h upon momentum. So a body who's having wavelength will also have momentum. And Heisenberg proposed Heisenberg's uncertainty principle, which says that you can't find the exact position and the exact velocity or exact momentum of an subatomic particle or electron. So according to them, electron is a wave. So now this concept is wrong. So for that, there was another model known as quantum mechanical model, also known as wave mechanical model of an atom. So we know that electron is a wave, right? So for that, but electron is not that, like electron is wave, but it is a matter wave. It is de Broglie's wave known as matter wave. Like it has dual nature. It will also behave as particle as well as wave. So for that, there was a scientist which gave the exact base of that quantum physics, quantum mechanical model known as Schrodinger. So he actually proposed electron wave equation, which tells the highest probability of finding electron. Now what is probability? Like you can't find, like electron is a wave, so how you can find the exact position of wave? Obviously you can't find the exact position of wave. So but you can find the probability. Probability means the chances of getting electron, chances of finding the electron. So he proposed a wave equation which was d square, this is xi, upon dx square plus d square xi dy square plus dz square plus 8 pi square m square upon h e minus v xi is equal to 0. So this was the whole equation which was proposed by Schrodinger in order to find the electron wave equation. So this was a very new thing. It was very interesting, and this was not an easy work. Like from this equation we can find the probability of electron, because electron is a matter wave. So you can find the probability of electron from this equation. So where xi, like here we have done double differentiation, where xi square is known as electron finding probability, because wave travels in 3 dimensions. We have used here dimension x, y and z. So when we solve this equation, like we have the equation which was given by Schrodinger, d square xi upon dx square plus d square xi upon dy square plus d square xi upon dz square plus 8 pi square m square upon h e minus v xi is equals to 0. So this is an equation which was given by Schrodinger in order to find the highest probability of finding electron. So when we do the solution of this Schrodinger electron wave equation. So it gave us three variables. It gave us three variables which represent the position of electron. So after solving this equation, we will find three variables which will represent the position of electron. Those positions where probability of finding electron is highest. So after solving this equation, we will get three variables. So obviously this equation is not in our course, but I have written. So the solution is also not in our course, but after, so we won't be doing the whole solution. But after solving this equation, we will get three variables. Why we will get three variables? Because we have used here three dimensions, x, y and z. So these three variables will represent the position of electron, that where the probability of finding the electron is the highest. So these three variables are known as quantum numbers. There are three quantum numbers because there are three variables, so three quantum numbers. But now there are four because one was discovered after this, which are n, l, m plus s. These are three which was found by using this Schrodinger wave equation, but s was discovered after this. Now quantum numbers. What are quantum numbers? Like why we need them? So quantum numbers tell you the exact position of finding electron probability is highest. So it gives you the position where the probability of finding the electron is highest. So it tells you the location or the address. So we are having four quantum numbers n, l, m and n. So where n is principal quantum number, L is azimuthal quantum number, where an m is magnetic quantum number, and n is spin quantum number. So we are having the quantum numbers for n, which is principal quantum number, l azimuthal quantum number, m magnetic quantum number, and s is spin quantum number. So now we have talked like what are quantum numbers. Quantum numbers tell you the highest electron probability. So now like where